This video is a partial video for your Unit 2 test review for the Blended Algebra 2 class. I'm only going to do about 6 problems here on this video. If you need help with the other questions, you need to check the key on Canvas or ask your teacher for some help. And I'm going to start with number 10. So number 10 says use the following functions f of x, g of x, and h of x to evaluate the function questions below. Now number 10 says to find the value of h of g of -3. This is a composition of function problem. In this problem, remember you always start with the function that is on the right. Here that means you need to evaluate the function g at the value of -3 for x. So you're going to look at g up here, 9x minus 1. You're going to put that -3 in for x. 9 times -3 minus 1. Well, 9 times -3 is -27. Minus 1 is -28. That is g of -3. Now, once you take that value, you are going to put it into the function on the left, which means you're going to take that value of -28 and put it into h as the input. So you'll have -2 times -28, which equals 56. 56 is your final answer. Let's look at number 11 now. Same three functions. F of h of 1/2. This time the function h is on the right, so that is the function we're going to start with by evaluating h of 1/2. Okay, and put 1/2 in for x, so I'll have -2 times 1/2, which is -1. And then that -1 goes into the function on the left, f. So we need to find f of -1. Well, that -1, make sure you put it in parentheses when you put it in for x. So if -1 squared plus 5, -1 squared is 1 plus 5 equals 6. So that's 10 and 11, a little bit of practice there with function notation and composition. Skip ahead to number 15. Number 15 gives you two functions, f and g. Okay, for these two functions, we're going to, again, do some composition, but notice this time the composition inputs are both x's. That means that our answers are also going to have x's in them. So again, we always start on the right, just like the last problem. So this function of f is going to go into the function of g. Remember, we like to start by writing parentheses where our x is for the function of g, and then writing the rest of the function. That reminds me that I need to take this function of f right here and place it in for x in g. So I'm going to put that right here. All right, now we started with the tough one. When we have 2x minus 5, the quantity squared, you need to make sure that you rewrite this squared quantity as 2x minus 5 times 2x minus 5. When you square a quantity, like 3 squared, that's taking 3 times itself. So this quantity, 2x minus 5, needs to be multiplied by itself. You're going to distribute here. 2x times 2x is 4x squared. 2x times -5 minus 10x minus 10x plus 25. You need to tack on your plus 6 at the end. Now all you have to do is combine like terms. These x's combine, so we have 4x squared minus 20x, and then the constants combine to plus 31. That is your new function, g of f of x. Now we're still using the same two functions, but this time we're trying to find f of g of x. So this time the g is going to go into the function of f. So that means we're taking x squared plus 6 and we're putting it in for x in f. So we're going to start by writing the function of f with parentheses where the x is, and replace the x with the function of g, x squared plus 6. Now you just have to simplify here. I'm going to distribute the 2, which gives me 2x squared plus 12, then our minus 5. And we finish by combining like terms. 2x squared plus 7. That is the value of f of g of x. Good. So that we've done a couple compositions now. Composition of functions with number inputs and number outputs. And then composition of functions where our output was a new equation. Let's switch to 21. 21 is just a review question. Remember we did some review of graphing, but inequalities are sometimes challenging to remember how to graph, so I wanted to go through this one with you. I think it says 20, oh no, it is 21, I'm sorry. All right, so let's solve this. In order to graph this inequality, we need to solve for y. So we're going to start by moving the x term. We're going to subtract 2x from both sides, and you're left with negative 4y is greater than or equal to 12 minus 2x. In order to get y by itself, you need to divide by its coefficient, negative 4. Now here's the big thing you need to remember here. When you divide by a negative, when you're solving an inequality, that sign needs to flip. It goes from greater than and equal to less than or equal to. 12 divided by negative 4 is negative 3. Negative divided by a negative is positive 2 over 4x, which you are allowed to leave as 2 over 4x, or you can simplify to be 1 over 2x. Either one, those are exactly the same. One just has a simplified fraction. Now we need to graph. So we start by identifying our y-intercept, which is the number by itself, negative 3. That's where we start. And we're going to follow our slope. Up 1, right 2. I want you to take a second and carefully plot those points. If you need to pause the video while you do that, go ahead. Once you plot those points, you need to decide what kind of line and how you're going to shade. If I see a less than or equal to, because it has the equal to part underneath, that means you're going to graph with a solid line. So you can connect your dots with a solid line. Then you have to decide where to shade. Less than means you're going to be shading below. So you put your pencil on the line, drag it below, and this is the portion of the graph you're going to shade in. We need to decide if these points are in the solution set. So 0, 0, if I plot it, that is definitely not in the shaded region. And if I go to 10, negative 2 over here, that definitely is in the shaded region. So those points, the first one is not a solution, the bottom one is. Now we're going to skip right to 23, the next problem, 22 and 23, because these both talk about inverses. They're just set up a little differently than what we did in our notes. So let's do 22a. You have a set of ordered pairs, and remember that ordered pairs are x's and y's. So each of these ordered pairs is a set of x's and y's. And when you are working with inverses, the main thing about inverses that happens is that you have to switch the x's and the y's. So the way you're going to write the new set of ordered pairs for the inverse here is you are just going to flip the x and the y in both ordered pairs. So instead of having 1, negative 3, you're going to write that as negative 3, 1. And you'll do the same thing for the next point. You'll flip the ordered pairs here. 3, negative 2. Flip the next two. 1, 5, and then 4, 6. You're not changing the sign at all. You're just reversing, switching the positions of the x's and the y's. So you can go ahead and try 22b. It's going to be a very similar problem. Then you can check your answers on the last page. For number 23 here, part A says first, graph the line y equals x on the grid. Well, remember, y equals x is the line that starts at the origin and has a slope of 1. So it's going to go up 1 over 1 all the way from corner to corner of your grid. I'm going to leave it as a dotted, no, I'm going to make it a solid line. There we go. So that is y equals x. Remember, that's the an important thing to remember about that is the line, all inverses reflect over. Okay. Now let's talk about our graph. It says B, we're going to graph the inverse of this parabola. So the way you graph an inverse is very similar to the problem we just did up here. We have all the ordered pairs are labeled. When you graph an inverse, the ordered pairs all reverse. So this point over here, negative 3, 8, the inverse of it is at 8, negative 3. So we can plot that point right here. This inverse would be at 3, negative 2, which would be here. Then 0, 1, and negative 1, 0. Okay? If I keep reversing the points, and I graphed that wrong, if I keep reversing the points, I should get an inverse here. Okay, so we'll be at negative 1. So go ahead and pause your video. Let's graph these. It's a little blurry for me, so it's a little harder to see. Oh, 0, negative 1. Here we go. Then negative 1, 0. And we'll keep plotting. There we go. So there's our parabola. It's all sideways now. You should notice that our new parabola does look like it flipped from the black graph to the pink one over that green line. Now let's do some review questions. Was that original parabola, this black graph that's on your paper, was that a function? Well, remember, functions pass the vertical line test, which this graph does. So that would be a yes. Is the inverse, the pink graph, a function? Well, the pink graph fails the vertical line test, so it is not a function. Then it says, what's the domain? We're reverting back to some old stuff here. Well, remember, domain is the x values. So our domain here goes from the left x value at negative 3. There's an endpoint there, so I can use a closed bracket, to the rightmost point at x equals 3. The domain of our inverse is from, I guess we don't have arrows on this one, left to right. So our leftmost x value on the pink graph is negative 1. And the rightmost x value over here is at 8. Now let's talk about the range. Range is the y values of a function. So on the black graph, our original, the lowest y value is here at negative 1. The highest y value is up here at 8. For the range of our inverse, the pink graph, our lowest y down here is at negative 3. And the highest y value right here is at y equals 3. You should notice something here. Notice these domains and ranges switch. That happens because when you switch, when you find an inverse of a function, its x and y values flip, which also means its domain and range flips. Okay. Those are a little bit a little bit more challenging questions, but still good ones. All right, the last problem on our video here. We are going to find the inverse of a line and we're going to graph them. So we have the line negative 3/4 x plus 3. Let's label this to start, or graph it to start. Your y-intercept here is at 3, and the slope is negative 3 over 4. So you're going to go down 3, right 4. Down 3, right 4. And I want you to do that in both directions so that you can connect those and then label that equation as f of x. That is the function we started with. Now we're going to find the inverse algebraically. And finding an inverse, remember, starts by switching the x and the y values. F of x is the same thing as y. So when I switch those, I get x equals negative 3 over 4y plus 3. Now if I'm going to solve that, I'm going to start by subtracting 3 from both sides, which gives you x minus 3 equals negative 3 over 4y. And we need to clear the denominator here. So I'm going to start by multiplying both sides and every term by 4. I'll have 4x minus 12 equals negative 3y. And I'm going to rewrite that up here. Because in order to get y by itself, I now have to divide every term by negative 3. When I do that, my slope here becomes negative 4 over 3x plus 4 equals y. Remember, negative over negative is positive. That is the equation of your inverse. That is f inverse of x. So when we graph this time our y-intercept is at 4, and the slope is down 4, right 3. All right, so we're going to plot those points. There we go. And we should be able to connect these the best we can. And that's going to be f inverse of x. All right. Now it says C. State the equation of the line that all inverses reflect over. We just talked about this on the last problem. Inverses always reflect over y equals x. That's really important to know. If we graph y equals x, remember that is the line that goes through the origin with a slope of 1. That line I just graphed right here. And you should see that your graphs look like they do indeed reflect their mirror images over that line. Now what we want to do is we want to confirm that these are actually inverses. So I'm going to write the functions down here really quick. We know that f of x, our original function, is negative 3/4 x plus 3. And we know f inverse is the function we just wrote. Negative 4/3 x plus 4. All right, now, in order to prove that two functions are inverses, remember you need to find f of f inverse. You need to do two compositions. Then you'll have to find f inverse of f of x. It tells you to do that in the directions. So what we're doing here is we start on this left one, f of f inverse of x. And take f inverse and put it into x. So we're taking this function and putting it in for x. So we start with our regular function, f of x. Put some parentheses for where your x is going to go. And we're going to put negative 4/3 x plus 4 in parentheses. Okay, now you might need your calculator here, so let's turn it on because we're going to have a lot of fractions. All right, so for this, we are going to need to distribute here so we can solve this composition. So I'm going to multiply negative 3/4 times these values in the parentheses. So this is where your calculator can be helpful because I need to take negative 3/4 times negative 4/3. So we're going to write our fraction. Negative 3/4 times negative 4/3. We get 1. That's a good thing. That's nice. We don't want another fraction. So this gives us 1x. And then let's multiply negative 3/4 times 4. Okay, so again, we'll make our fraction. Negative 3/4 times 4. Look, that gives us negative 3. Which is really nice because I now have x minus 3 plus 3. Those 3's cancel off, and you're left with x. Remember, that's a good thing, because if two functions are inverses of each other, their composition should give you the answer of x. Now let's go the other way. Let's verify. Let's put f of x into the equation for the inverse. Okay, so other way now. So we start with negative 4/3. And inside for x, we're going to put in the original function that we started with. We're going to distribute. Now, it's going to save us a little time because we already calculated a minute ago. Negative 4/3 times negative 3/4. That's up here. And we got 1. So we can skip right to 1x. So let's see, negative 4/3 times 3 So we'll take negative 4/3 times 3 gives you negative 4. You can see that that's a good thing. Minus 4, but then I bring down my plus 4, and just like the last problem, those values cancel off to give you an output of x. Because both compositions gave you an output of x, that verifies that they are indeed inverses of each other. There are a couple other questions about these on your review. I want you to give them a try and check your answers. If you need more help or more explanation, talk to your teacher.